Alright, so this is where we stopped last time. We finished all these, get last, etc. And we did not do this find min and find max. Now this find min and find max, in order for them to work, we need to do some extra things that I want to share with you. For example, now if we have this kind of implementation of the lists, I can just go to the navigator. It will be easier for me to see all the methods that are there. These are the length that we've just finished, is get at a specific index and so on. Print in reverse. This is what we did last time. Now what I'd like to do is to do this find max and find min. How would I do that? Now if I'd like to do something to find the max or find the min, how do we do that in an array? The first thing is that we take the first element and say that this is our minimum, for example. And then we compare with each one, and if we find a smaller one, we changed, not we changed, yes, we changed our minimum. Yes, remember that this is our minimum. So in order for us to do that, we need to be able to compare less than for the minimum, greater than, or something like that, to find the maximum. Now how can I compare a class that is T? Now if I'd like to compare, I will compare the information in the node, and what is the information of the node is data type is T. So how can I compare anything like that? I'm sorry? The main should be T, but how can you compare like two T's? Because T can be a student, can be an int, an integer. For an integer there is some kind of comparison that is possible, because there's integers or doubles or whatever, because these are numbers. But what about the students, items, whatever the other classes can be? Because we can use that with item or with a student, wherever. Walaikum salam. But the first letter of what? Which information? The information is a class. The information is a student. Or it's an item. Or it's a scanner. Or you don't know what kind of information is this. You don't know what kind of data type is that. It can be a string. It can be anything. As long as it's a class, this is what this T does. Instance of, then we can compare. Okay, so now you can ask a question that this is how we compare the student, this is how we compare an item. Well, that's a way to do that. So let's try to do something like that. There's one problem, is that when we do this kind of method, now we need to have a method called to be able to compare less than or greater than. There's something that exists which is called the method, the interface called comparable. Have you ever heard about this comparable? Comparable is an interface. You know what an interface is? What is an interface? That's the heading without any value? It's not a method. Heading, an interface is not a method. It's same like the class, but it has only method declaration, which basically all the methods are abstract. Can it have some instance variables? Instance variables? No, you can't. Only if they're finite. How can have constants? So not variables. So now I want something. I want this class T not to be any class, but only a class that is, I would like to put a condition of the class. And remember, in the generics, we can put some kind of conditions. Or have you ever seen that? No? Okay, let's say if I do something like now what is the key word to say that this is inheriting is a subclass of something? Extends, right? Now this extends, I can put it also here. But you need to make sure that you choose something. Now by doing this, I'm putting in a condition that this t that I'm referring to inside here, this class, this t is extending a number, which means now this is not going to work with any class, but with any t. If I do something like this now, if I try to call this with a student, I can't now because student is not extending numbers. But if I do this with an integer or double, that is fine, it works, because this integer or double, they extend number. So you can put this kind of condition, and look, it does this, implements comparable. Why? Because you can compare two ints and true, less than or greater than. So this is basically what I mean by putting a condition on the data type that is the generic data type there. So you can put a condition like this. Now what if I would like to put a condition that the only thing that I'm going to do is something that implements comparable? There's no implements. So can I do something like this? So what I'm saying now, any of these, this t, anything can be accepted as long as the class that you're going to be using have this comparable. And what is comparable? Comparable is an interface. Comparable is just an interface that has only one method. So what's the purpose of this method? Compare to. And you can read some of the documentation here. Maybe it might be easier to read it like this. This compares this object, the one that is going to be used to call the method, with the specified object as a parameter, and returns a negative number, a 0, or a positive number if this object is less than the other one, or equal, or greater than. Let me translate that for you. What is called paint? Come on, Windows. All right. And just be patient. So if I have something like, say, I declared student S equal new student whatever, new student, etc. Now if I use s dot compare to, anyways, you get it. Compare to, alaikum salam. Now I need to have another student. So let's say this is S1, and I have another student, S2, which has new, etc., etc. And I compare to S2. And this is how I'm going to call it. This compare to is going to be returning an int. It returns an int. Now this int, what could it be? It's either -1 0 or 1. -1 when this S1 is less than S2. 0 if they're equal. And S3, no, it returns 1 when S1 is greater than S2. So which means now every class that I wanted to implement comparable, I'll put some kind of rule that will tell me how can I compare two objects from this class. So if I have an item, I can choose how to compare between two items. Maybe if you remember the class item, I'm not sure that you remember, so I'm just going to put it back here. Has a name and price. So how can I decide that which one is less than the other? I can choose based on the name. Or no, I want based on the price. So I'm the designer of the class who is going to decide how these two objects from this class are going to be comparing. Yes?
For the name, count only method there and compare?
Well, compare, it's again up to me. There's class actually string implements comparable. So you can compare two strings by having compare to. So it just compares the first letter with the first letter of the other one and look which one is the smallest. If they're equal, compare the second with the second one, which one is the smallest. The smallest is the one that comes first. Like A is smaller than B, is smaller than C, and so on. So, but it's up to me to decide based on what. Is it based on the name, on the price that I'm going to be choosing? And how I do that is that basically I just say implement comparable. Now, comparable of what? Well, comparable of item, because I'm just comparing two items. Now, as soon as I do this, this is going to tell me there's a problem because I don't have this method that is called compare to. So I have two options. Either I implement the abstract methods from that are needed by this interface, or I just make the class abstract. But I'm not interested in making the class abstract, so I'm going to implement all the others and see I have now this compare to that I have to put some code in it. So how can I compare two items? Well, remember I need to return an int, right? So I'm going to say this is the result that I'm returning, and let's not put anything in it. I'm going to have some kind of if else. If what? If this dot price is smaller than this O dot price, then I'm going to return -1. So this one is smaller, so I'll do -1. Else if they're equal, then return 0. And we have else. I just messed up these things. Else I return 1. I mean, it just needs to be positive and negative. It doesn't matter it's 1 or whatever. It can be 200 if you want, but just this is what generally everyone is doing. Put in -1, 0, or 1, just not to be too fancy and kind of be consistent with others what they do. So that's the idea behind that. So I just want to show you that if I look here, look for compare to somewhere. This is compare to, and if you look this, okay, it goes compare. So it returns -1, 0, or 1. You remember this notation with question mark? I think I showed this to you once. I did not. Well, this is an if. If this is true, that's the question. If this is true, return this. Else, return that. This one. So if this is true, return 0. Else, return 1. But anyways, you return either -1 or 1 or 0. So anyways. So now that I have this thing, now I can compare two objects. If which one is smaller than the other one, I can know, because I can ask a question and I will know which one is smaller than the other one, or if they're equal. How to do that? Let me just go to, this test item. I don't care about all these things. What I'm going to do basically is just one thing. I'm having an item 1 equal new item, and let's put the string is item 1 and the price is 1, and copy paste item 2 price is 2. Now what I can do, I can just put everything in comments for now. Now I can ask a question. What is the question? If item 1 dot compare to item 2, if this is negative, I know that item 1 is smaller than item 2. And I can ask all the questions just to, if this is equal to 0, that means they are equal, is equal to item 2, and else this let's just greater than is greater than item 2. So it's well, it can ask me replace this with the switch, doesn't matter. So let me run this. I don't know if it's not going to run that one. Let's cancel. So let's run it again by just right click and run the file, because the one that is set, it says run anyway. This file has a problem. There's no red line, so why is it complaining? Let's run the file again. Yeah, maybe this one, but I'm asking about the file. Just run anyway. Maybe the project has a problem, so that's why it's telling me. So item 1 is smaller. Let's change that. And run it again. Yes. So item 1 is greater now. And if you put them equal, and just to make sure that it works in all cases, yes, it is equal to item 2. So this is how it works. Now I have a way how to compare between two objects. And that's what I'd like to do. Now, I'm not interested into this. Let's just go bring it back how it was. And I'm not going to do any of that. Let's just, since we're working with students, now students is complaining because our student does not implement this comparable. It doesn't want to help. Implements comparable. Now implements comparable, I just need to comparable with students, obviously. And it tells me now I have to implement all the abstract methods. Yes, and we have only one, which is this compare to. So what are we, how do we compare? Actually, you know what, this O is kind of, I prefer other. Even with the item, it makes more sense to have this to be other than just O, because when you make it other, it's kind of easy to read. This one's less than other one or greater one, something like that. But basically I'm going to do the same. I mean, I did this result, it's not really needed. Yeah. So let's do the same here. Now, how do I compare two students? Now it's up to me now to know how they are less than or greater than each other. Well, basically we use the ID, let's say. So because when we also try to find or say if it's the equal, we were comparing the ID, if you remember. So we were comparing the ID. So to be consistent, we should just order sort by the ID as well. So this is what we're going to be doing. All right, so we ask a question, if else this .id is less than the other .id, then I'm going to return minus 1. Else if hold on. Else if this ID is equal to the other one, then I'm going to return 0. And the last one, else if it's not that case, there's no other option, I'm going to return 1. I forgot the semicolon here. And now I'm set. Now I'm set to do this thing that I wanted to do, which is the find min and find max, because now I have a way how to compare between these things. So let's just summarize what we had to do. First of all, we had to put a condition that we're not accepting any class in this doubly linked list. We accept any class that implements the comparable, and that's how we did it, by putting this extend. Yes?
Why do you use extend instead of implement?
Because implements is not acceptable. It's not shown here. So they're using extends even though this is an interface, because we just would like to put a condition that we say that we would like to this t is going to be extending any class that implements this interface, which means that this t, I mean, should be implementing this interface. But yeah, it's kind of confusing, but this is what it means. Yeah.
So it extends any implementation of the interface.
Yes, every class that implements comparable. Now the idea is this, what this does, it just puts a condition now on this t. We don't accept anything, we accept specific ones, only ones that respect this condition, which have comparable as an interface that they're implementing. As you have seen before, we had the problem with just trying to have this first line. Which one here? This first line was a problem. Now it's not, because the student now implements comparable, so it fulfills this condition that we just put here. Now this t here is the one that is used anywhere, so even the node now is the same. So that means no, the node here is kind of different, as you can see. So if I put a condition here, for example, just to show you that this is not included, this t is just a like a variable name. I can change it whatever I want by using the same control R. I can call it, let's say, type. So whatever the type you put here, it doesn't matter. This is just a variable name. That means there's a data type. Now notice if I change this to type, did it change also in the node? No, it didn't. Which means if I put a condition here, I need to put it as well there, because I want this to be consistent. So let's put it back to t, and I'm going to copy this, go to the subclass, and paste it. Now what I'm saying as well is that this t needs to also extend comparable. Why? Because we would like to be consistent, and what we accept only something that can be compared, because we would like to be able to find the max and find the min. All right, let's close these so we don't get confused, and we focus now on this one. Not really on this one. Now we'd like to be able to find the min and find the max. So now, how do we do that? Once we find the min and find the max, we will return that object that is the min or the max. So now let's just do something. In order for us to be able to find the min and find the max, we still need to, as I said, we need to start from the beginning. I'm just we don't need, let's just go back to here, and yeah, let's say from here, public t find min. Now this find min, does it take any parameters? Not needed, because it just finds the minimum. So we need to return, like, let's say t is the minimum, and we need to put the minimum to be the first element of the list and then check among every element in the list if we find another minimum, and we need to use a loop to do that. And then at the end we're going to be returning this min. But in between we need to do something. Now the first thing is Walaikum salam, is we put this to be the head, right? Because we said we put the first element as a minimum and then we check with the rest if it's something that is going to be not the minimum. So the first thing we do is to put this to be the head. But then we have this problem. What is this? It says incompatible types DLLT node can't be converted to T. What's the point? No. Exactly, yes. So it's not head, because the head has three parts. It has the info, the previous, and the next. While this is just the info that we want. So it's just not, it's head.info. But hold on, there's a problem. What if the head is null? There's nothing in the list. Is there something that says what we need to do? No. So we need to check, because if the head is null and we do something like this, this is going to raise an exception. Null pointer exception. Always remember that. When you use an object that can be null, you cannot do this unless you check that it's not null. So now, if I need to put some kind of if else actually, because if the head is null, well, I can just return null. There's nothing to return. There's no info anyways. There's no minimum because everything is empty. Else, then I can do something like this. So basically, what I'm going to do is, anyways, when I have these long codes, I prefer to have something like this. I do this to be null. So I initialize it with null, and then I ask if this is different than null. I'm going to do whatever I want to do. I'm going to do this, put the first element to be the head, and then loop over, etc., etc. So if the element is equal to null, I'm not going to get inside here. I'm just going to return null. Okay. So now I need to loop. So I need a for loop. Okay, that will start from where? Yes. Well, the loop, the condition should just then not work, because if whatever the condition, the initialization is going to be, and the condition is going to be what? Now we need to have something like set the temp. Now this temp dot next. If it's different than null, then I should move out. But if it's null, I should stop. So which means now if it's only the head, we have only the head, the next is going to be null. So this question is going to be false, so I'm not going to get inside the for loop. So now I need to initialize that, so I need to have DLL node T, that is going to be temp. So it starts from where? From the head. Right? Well, we selected the head. Yeah, let me just draw something. Well, there's no more. Okay. Okay, we have. Let's say we have this list. 1, 2. Maybe just 1. Okay. This is the head. This is the tail. Now we have whatever the value is. This is next. This is previous. All of them are null. Now I put this to be my minimum. So I say this is the minimum now. The next thing I should do is that I should take the next one to check if this is the minimum, but there's only one, so this is going to make this loop stop, and that's it. I'm going to return the minimum. But if I have more, now if I have more than one element here, and let's me just, okay, we can keep this here. If I have more than one element, then if this one, the first one, it says 5 and the other one is 2, this is going to be pointing here, this is pointing there, there's no previous, there's no next. So this one is here and this one is there. And this one is the tail. Now my minimum is pointing here. And my temp also is pointing here. So many places, so many things are pointing to. So now I start with the head. Let's say I'm asking, is temp.next different from null? Well, yes, it is. So if it is different than null, what should I do? So when I'm inside, I'm going to, now this temp should be pointing here, right? So how do I do that? Is temp now is equal to temp.next. Because it's not null, so there is another node. And then we should compare now this with our minimum, that we said that this is our minimum. Then, so how will we compare? If minimum compare to temp.info, so then if this is what? So we compare the minimum with the information of the temp. If it's less than, no, actually, if it's greater than, if this minimum is greater than this information that is in the temp, this is what I need to do something. So if it's greater than 0, or maybe if I can say if it is greater than 0, that I know that this min is greater than this temp.info. What I'm saying is if this minimum is greater than the temp.info, that means my minimum should not be this one, should be the temp.info. So that minimum is going to be temp.info. Well, else there's nothing to do. Just keep moving.
Why do you compare between the temp and the temp.next?
Between temp,
And temp.next.
why did I compare between temp and temp.next? Because
The info side. Why didn't you
now,
use the
okay,
compare to?
okay, hold on. Now this is where it was, right? It was, this is how we were. After just this line here, we are here, right? Now you would like to compare. Now I would like to say, I ask this question, just I start the temp to be the head and the temp.next is not null. Once it's not null, I get inside, I move this to be, now the temp is going to be on the next node. This is where the temp is. So I executed this thing, then I compared this value with this value. Now if you compare temp with temp.next, well, temp.next first doesn't have anything. Temp.next is null. So there's no need to compare. But what I need to compare is this one with this one.
Yes.
So this one is what? This is my minimum that I said that this is my minimum.
First one, yes.
So I need to compare the minimum that I said this is my minimum and see if it's greater than another element in the node. And the next one that I'm comparing is the one that is in temp. So that's why I need to compare the minimum with the temp.info, not the temp.info with some temp.next.info. because first of all, it doesn't exist in this case. But now that I did this, what's the next step? Now, in order for me to know that maybe clearly, let's just add another node. Let's say that our tail is this one, and we want to make it 1 again, to make it even smaller. So this is our tail, and now let's see what would be the code, so we can see if it's okay. Now this is the first step. Let me take a different color for the next step. So now once we did this, I mean this here is going to move the minimum to be now pointing to here. This is what this if is going to do. All right? What's the next step? What should I do next now? Now remember, just forgot to do this. This is pointing to here, and this is pointing to here, and this one is null. There's no next. Which means now this is, after finishing by comparing this with this second element, I need to compare this minimum now with the third element that I have. Which means my temp here needs to move to the next. I'm sorry? I'm sorry?
It's gonna do it in the
So do I need to increment anything?
no.
Nothing really needed. So basically, I could just move this here. Why didn't I do it there? I mean, there's no need for the semicolon.
But now it's gonna be wrong for the first one
It's going to be wrong. Why?
because we
No, this becomes too crowded. So let's say this is our. Okay, let me just go back to this. This is our first one, third one. Let's say now, let's run it again and see what if we do this, what would be the change? Now, okay, this is pointing to here, and this is pointing to here, and this is empty. This is null. This is our tail. The temp we started to be the temp is pointing here at first, and the minimum is also pointing there. So this is what we did. We put the minimum to be the head.info, which means actually it's not accurate, this minimum. Actually the minimum is, let's say, I'm going to put this is equal to 5, because it's not pointing to this node, it's pointing just to the info itself. So let's say for us it's just 5, the information. And then now we come here. Temp is going to be initialized to the head. That's what we did. Is temp.next different from null? Yes, it is. Temp.next is different from null. We get inside. We compare the minimum with the temp.info, which is basically just comparing it with itself.
yeah, so it's wrong.
Well, it's not wrong. It's just doing something useless.
Not doing it.
It's like when you initialize with the array, that the first element of the array is your minimum, and you start your for loop from 0 until the end. You're just going to compare the first element with itself again, which is something that can be avoided. But let's just see, is this wrong? I mean, does it going to give us something wrong? Not really.
No.
So it's not a problem for now.
Can we change in compare to we put temp.next.info?
Well, let's just now not focus on this and look at the improvement later. Let's make sure that it still works with the minimum, and then let's improve it to not do something useless for nothing. So now just we put this, we compare this temp.info with this. If it's equal, if is this greater than? No, it's not. So it's going to go here, increment the temp to be the temp.next. Now it's going to ask the question, is temp.next different than null? No, check this, what I'm asking. This is not right. I'm asking not if temp is null. I'm asking if temp.next is not null. And this is something weird. So it should not be asking about. Now what I should do, I should ask if is this null. Not if this dot next is null. Why am I interested in this dot next? The temp dot next is not interesting for me.
Temp.
It's temp. Because when the first time what I did something like this basically. This is what I did the first time. The first time I went to the next to the head, and this is what you were looking for by trying to say, what should I do? Now, instead of starting temp to be the head, I'm starting temp to be the head dot next. So this is how I initialize the temp. Now the temp does not start with the first one because I know the first one I checked it. I assumed that this was my minimum. Now I'm asking this one now, is it null? Is it different from null? Yes, it is different from null. So I get inside. Now I'm going to compare with this just small change by putting this to be next and removing this from here because this was needed, but this is what is the optimized way to do it. But we had to do this because we needed to realize that this is not okay. Because what we did is that the way I typed it the first time was not fully working as a loop. So I had to adjust it to make it work as a loop. So now, let's just roll back and see what just happened. Now we said that this temp is not going to be the head, but we want it to be the head dot next. And let's see if this is still going to hold. Temp is equal to head dot next, which means I say that temp is not going to be pointing here, but pointing here. And then I'm asking, is temp different from null? Yes, it is different from null. I get inside. Now I'm going to compare the minimum with this 5 compared to the temp.info with 2. Is 5 greater than 2? Yes. So now my minimum should not be 5. It should be 2. That's what I'm doing. Now the next step that should happen is that the temp is going to be temp.next, which means this is going to be now pointing to this one. And then I'm going to ask, is temp different than null? Yes. Get inside, compare the min, which is the 2. Is it greater than the temp.info? Yes. So change that, make the temp.info to be the minimum, and then make the temp to be temp.next, which means now temp is null. I'm going to ask, is temp different from null? No. Get out. And then the min is going to be my minimum that I just found. Yeah. Compared to will do that you have to look at the video after you finish it because you came late. That's what it does. So to summarize, compare to gives you either -1, 0, or 1 based on if this one is lesser than this one, or greater than or equal to that one, or if the first one is less than the other one, or the first one is equal to the other one, or the first one is greater than the other one, there's going to be returning -1, 0, or 1 based on that scenario. On which scenario? Have a look at the video. So now what we'd like to make sure is that our code works in all cases, which means what if we have only like nothing? Let me just this, yeah. Now what if we have like the head and the tail are null, so which means there's nothing. This is going to be null. Is the head different from null? No. I get out, I return null, so that's fine. Now what if we have one element in the head and one element in the whole list, and let's say this is our 5, and this is the head, this is the tail, both of them are pointing at the same place, and null. I'm going to ask a question, is the head different from null? Yes. I get inside, I put the info as my minimum. Now my minimum is 5, this is my minimum. Then I declare a new variable, call it temp, that's going to point to the head not next. What is head not next? It's null. So the temp is going to put that null. So this is going to be null. The question is temp different from null? No, I get out, so it still works. Now if I have 2 or more, let's say this one is smaller, This is going to, the next is going to be null, the previous is going to be pointing to this one, and the next now is going to be pointing to this one. And now when we ask, the temp is going to be head.next. Now the temp is going to be pointing here. And then is temp different from null? Yes, it is. I get inside, I compare this min with temp.info. Is minimum greater than temp.info? You know, there's a way how to see it. They made it in a way because you see, this minimum, is it greater than this operator? If you do it this way, it's going to be like easy for you, because this, when it's -1, it's going to be, lesser than, so it's going to be like this. So if I do now, is minimum smaller than temp.info? That's how it works. If I use the equals, well, it says it's equal. And if that's why if you use the 0 to with you the compare to, it's going to be much easier for you to understand and not get confused with this -1 and +1 thing. So if the minimum is greater than the temp.info, which is the case, then I get inside and the minimum is going to be temp.info. So now my minimum is not this one, but my minimum is this value. And then the next thing I do is temp is equal to temp.next, which is going to be null. Is temp different to null? No, get out and return the min, which is going to be 2. So this is going to work regardless of how many elements do I have in the list. And this is the find min. Now, find max, copy paste, change this to max, rename this to max, and we do exactly the same thing, except that
I'll change
if the max is smaller than the temp.info, change it. And here we go. So finding one will find the other one. Yes.
Can we also use the same method to find the number?
What do you mean find the number?
Like
We have some find already. We have a find somewhere. Yeah, here. So we have something that loops until it finds it with the equals. So because the find, it has to be equal. So that's why they did it this way. I mean, this is something that is almost like we did. Look at this. Well, almost.
yeah,
We start from the head, and then instead of starting from the head.next, we start from the head. We ask if it's not null. We increment, except that we ask another question. We want it not to be null, and we don't want it to be equal, because if it's equal, we would like to return it. We stop the loop. So we stop at that node, so we don't stop at the end.
Compare information inside info like temp.next.info compared with temp.info.
Temp.next.info.
Compare it with
You can do that if you want, but this is, you have to make sure that there's no null in the discussion, because if you say temp.next.info, you make sure that temp.next is not null, because if it's null, it's going to have to be a null pointer exception. So you just need to, for example, here we're sure that this temp.info is not going to be null because we just asked the question before. You remember this difference between this and this? And this. Remember the difference? It's completely different. If I put just one, this is not going to work. It's going to raise an exception. One day temp is going to be null, and this temp.info, if I do this, that means I'm always going to ask all the questions. If I do something like this, that means it's a shortcut questioning. If it knows that if this one is false, with an end, one of them is false, the rest is going to be false, so I don't need to keep asking the questions. And that's why this is important, because I don't want to ask this question if this is false. That's why this is absolutely needed to have these two and as compared to if I put one. Because if I put one, I mean I'm telling the compiler to always ask the questions, regardless if it already knows the answer that is going to be false. Just keep asking anyways. If I ask anyways like this, this is going to raise an exception when temp is going to be null. And one day temp is going to be null because we would like to navigate until we find the end of the list.
you can do it in the
With the find min and find max? No, because here when we find it's equal, we stop. We don't need to keep looking. But with the minimum, if we find one that is smaller than the one that we said that was the minimum, it doesn't mean that maybe there's not another one. We need to keep going. So that's why, like the case when we have 5, 2, and 1. If we do put the condition in this the same way like this, once we find the 2, we stop. But maybe the 1 is smaller, and we're not going to be checking that. So that's why we need to keep going. It's slightly different than the find. The find, we find it, we stop. The find the minimum, we need to check until the end of the list, because maybe we find one smaller, but then there's the smallest is far later. So we need to keep going until the end. All right? Nasser is okay? Nasser is, I don't know, it's really not okay. But anyways. So this is the find min and find max. Yeah. If there is another element, I mean like this one, and if you have 4, yeah. Well, it's this the loop that we created is going to check until the end of the list, because let's go back to here and see the find. Where is the find min? There it is. So we are going to repeat and go to temp equal temp.next until we reach that temp is going to be null. So the next does mean there's no next. So this is going to work regardless of how many nodes we have. And we had to do this just to avoid asking a question. And we know that if we do something like this just to make the same type of loops that we've been using to, it still works, but we're just doing something for nothing. Because now we put the minimum to be the first node, and we ask, is the minimum the first node? Well, we just assumed it was, so it's not going to be. But this is much better. And we're sure that we're not going to be asking a question, because if this is null, temp is going to be null, and we're not going to get inside. So we're not going to be having this temp.info executed unless it's not null. When it's not null, then we get inside so we can get the info to compare it with the minimum.
It's null, it's already initialized as hit. Hit is the minimum.
Which one is null? The temp? If temp is null, I don't get it. I don't get your question. You say that if temp is null, it's because?
If temp is null,
Okay.
the minimum is the hit.
Well, I don't know. It depends. How many elements do you have in the list? How many elements do you have in the list that you're asking the question about?
The first one. First one is you initialize the hit to info.
Okay, yes, this one.
Then you ask the question, is the temp equal to null?
Is it?
Is temp not equal to null?
Yes, here, yes.
But if it's equal to null,
I'm not going to get inside. So it means, as you said, now, if temp is equal to null, what does it mean? That means that the head dot next is null. That means there's nothing after the head, which means we have only one element, right? So if we have only one element, this is going to be null. We get out and we return the min, which is the head.info, which is right. Yeah. But these kind of questions, these are the ones that helps you understand. So I have to keep asking them. Any more questions?